Now let us see another interpolating polynomial, Hermite. Hermite interpolation. Hermite interpolation. See, previously interpolation conditions, what are the given interpolation conditions? P of xi equal to f of xi, right? Only we have taken these interpolatory conditions. Coming to Hermite interpolations, not only the function values but its derivatives also satisfies the interpolatory conditions f dash of xi. That is the concept of Hermite interpolation. Okay, now see what is the definition here. The Hermite interpolating polynomial, the Hermite interpolating polynomial interpolates not only the function, interpolates not only the function, that means f of xi, but also its certain order derivatives, at a given set of tabular points, the simple what are the interpolating polynomial, right here, right? The interpolating polynomial here, the interpolating polynomial, what is that interpolating polynomial? P of x satisfies the interpolatory conditions, What are the interpolatory conditions in Hermite polynomial? Interpolatory conditions, the first one is P of xi equal to f of xi, okay, for I equals to 0, 1, 2 and so on n, means n plus 1 conditions for the n plus 1 data points. 0 to n means n plus 1 points, and the first derivative conditions also, P dash of xi equal to f dash of xi. These are also for I equal to 0, 1 to n. So totally how many conditions? N plus 1 here, n plus 1 here, 2n plus 2 conditions, right? Since there are 2n plus n plus 1, n plus 1 means 2n plus 2 conditions. Since there are 2n plus 2 conditions to be satisfied, P of x, what is its degree? P of x must be a polynomial of degree what? Less than or equal to what? 2n plus 1. 1 less than 2n plus 2 actually. Okay. For example, length of the data is 3. You will get less than or equal to 2 polynomial. Length of the data is 5. Then you will get maximum 4th degree polynomial, like that. Okay. Therefore, the required polynomial may be written as what is that? P of x equal to, required polynomial may be written as P of x equal to summation I equal to 0 to n aix into f of xi plus summation I equal to 0 to n bix into the derivative f dash of xi. One is for what? F of xi, another one is f dash xi. Since the Hermite interpolation interpolates the function as well as its derivative, the polynomial p of x is taken as combination of these two. Take this as equation 1, where aix and bix are polynomials of degree less than or equal to 2n plus 1, and satisfies, this is important, and satisfy the interpolatory conditions. What are the conditions? Satisfies the conditions. Satisfies the conditions. What are the conditions? First one, you write like this. Yeah. First one, ai of xj, ai of xj, okay, is equal to 0 for I not equal to j and 1 for I equals to j. Means what? ai of xi equal to 1, otherwise it is 0. Otherwise it is 0. And another one, you take like this. It's a derivative, vi of, what is this? b I of x, bi of xj equal to 0 for all ij, for all I comma j. These are the first condition and second condition with respect to functions. Coming to third one, derivatives condition. Third one, derivatives. What is that? ai dash of xj, ai dash of xj equal to 0 for all I and j, for all I and j. And the fourth one, b dash of I comma xj, b dash of I comma xj equal to 0 for I not equal to j and 1 for I equal to j. That means what? Remember, ai is 1 for I equal to j and b dash is 1 for I equal to j, right? Remaining b and a dash equal to 0 for all I comma j. These are called interpolatory conditions for Hermite interpolation. Now since aix and bix are polynomials in x of degree 2n plus 1, so maximum degree, we write aix equal to, aix equal to, one can write this as gamma I of x into li square of x into li square of x. Another one, bix is equal to delta I of x into li square of x. Take this as 2. Okay, all this is 3 and interpolatory conditions as 2. Okay, aix equal to gamma ix into this one, where lix are the Lagrange's fundamental polynomials. Lagrange fundamental polynomials. Lagrange fundamental polynomials. That means what? X minus x naught, x minus x1 up to x minus xi minus 1, x minus xi into whole by replace x by xi in denominator. That is Lagrange polynomial. Okay, and Lagrange polynomials. Next one more point is what? Since aix and bix are both, you write like this. What is this? ax, bx are what degree? 2n plus 1th degree polynomials, right? Okay. Then since, you write like this, since li square x is polynomial of degree 2n, lix r means what? Nth degree polynomial. Li square whole is 2nth degree polynomial. Gamma ix and delta ix, what is the degree? Already 2n is over, and what is the whole degree? 2n plus 1. So gamma ix, this is nth degree polynomial, 2nth degree polynomials, li square. So these two must be first degree polynomials. Lix and delta x must be linear polynomials, nothing but first degree polynomials, linear polynomials. Okay, now you set like this. Let write like this. So first degree polynomials means one can write gamma I x equal to ai x plus bi, and delta I x equal to cix plus di. Cix plus di. Take this as set 4, where I have to calculate this where we have to find, where we have to determine ai, bi, ci and di values. Okay, how you will set, let us see. Now equation 3 becomes, what is equation 3 becomes, aix equal to, substitute gamma. What is gamma? I have taken aix plus bi multiplied by li square of x. Another one is what? Bix equal to cix plus di multiplied by li square x, right? This is, take this as equation 5. Now let us use the interpolatory conditions. What are the interpolatory conditions? 2. Using interpolatory conditions 2 on 5. What is the first one? At x equal to xi, ai of xi equal to, equation 5 implies ai of xi equal to ai xi plus bi, right? Li of xi. Okay, this implies, what is ai of xi value? 1, and this is ai xi plus bi. ai xi plus bi. This is the first equation, one equation. Next, at x equal to xj, for example, if I consider second one, at x equal to xi, now in equation 5, let me consider bi of xi, equal to cixi plus di into li of xi, okay, square. Here what? Here I'm giving the condition, since ai of xi equal to 1 and Lagrange's fundamental polynomial, this is also 1. Okay, and coming to here, since bi of xi is always 0 for all ij, and li of xi value 1, so what is this becomes? This is 0 equal to cixi plus di. Now at x equal to xi, coming to derivative conditions, let me consider derivative conditions. What is this? Let me write differentiating, because derivative interpolating conditions are there. Differentiating 5, what I'm getting, ai dash x equal to ai into 2 li of x into li dash of x, right? This is one. Next one, bi dash x equal to ci into 2 li of x into li dash of x, right? Now at x equal to xi, what is a dash I of xi equal to, okay, what you will get, ai into 2 li of xi li dash of xi, okay. From this, what you will get, this implies ai dash of xi is what? 0 equal to, okay, 2 ai li dash of xi. Why? Because what is the condition? Derivatives are always 0 for a, 0 for all I, for all ij, okay. And what is li of xi value? 1. This is the first condition, 0, okay. This is another part. Next one, at x equal to xi, coming to b dash I of xi equal to ci into 2 li of xi li dash of xi, and what is this value? 1 equal to 2 ci Li dash of xi, Li dash of xi, isn't it, right? So the conditions are, this is 1 and this is right. So this is another condition. Same logic here. What is the reason? Since b dash of xi, b dash of xi, b dash of xi equal to 1, right? And li of xi equal to 1. So solving the above equations, solving the above equations, okay, we get, solving the above equations, we get ai equal to minus 2 li dash x of xi, this is ai. Bi equal to 1 plus 2xi li dash of xi. Next one, ci equal to 1, and di equal to minus xi, okay. These are the conditions. And coming to the conditions, somewhere I did mistake. What is ai now? Aix equal to what? Aix equal to aix plus bi multiplied by lix multiplied by li square x. Therefore, what is ai dash of x equal to function of x uv method. So first one derivative is ai, li square x. Next one, take this term as constant, ax plus bi, and 2 lix, its derivative, 2 lix, and lix derivative li dash x. Now at x equal to xi, what is this becomes? ai dash of xi equal to a into li of xi square plus ai xi plus bi into 2 li of xi li dash of xi, right? What is this value? Ai, this is a dash, a derivative is always 0, and ai, this value is 1, and ai plus bi, from the previous substitution, what we have, this value 1 into 2 li of xi value 1, and li dash of xi as it is. Therefore, what I am having, ai plus 2 li dash of xi equal to 0. This is another expression, right? Next one, what about bix? Bix equal to cix plus di multiplied by li square x, right? So it's a derivative now. Bi dash of x equal to this is uv method again. First one derivative ci li square x plus cix plus di multiplied by 2 lix, and lix derivative li dash x. Now bi of xi, b dash of xi equal to what? ci into li square of xi plus cixi plus di at x equal to xi, 2 li of xi li dash of xi, right? So what is this value? This value is 1 by interpolatory conditions, p dash. ci into this value is 1, and what is this value? This value is 0, okay, from the previous expression. Okay, this implies ci equal to what? 1. Ci equal to what? 1. So finally, what we are getting finally, what we have, ai equal to minus 2 li dash of xi. This is ai value. Next, bi value is what? 1 plus 2, bi value 1 plus 2 xi li dash of xi, li dash of xi, and the ci value is 1, and the di value simply minus xi. These are a b c d values, right? Therefore, hence, substituting these values, okay, we have, what is the polynomial? Finally, we have p of x equal to, remember this, p of x equal to, after simplification I am giving I equal to 0 to n, 1 minus 2 into x minus xi. Okay, otherwise let me write this expression. What is the first one? ai into, right, ai into, what is this one? We have, what is a polynomial? Summation I equal to 0 to n aix into f of xi plus summation I equal to 0 to n bix into f dash of xi, right? What this becomes? What is ai? You know what is ai? After substituting ai, what is that? ai delta gamma ix into li square x. What is gamma I? aix plus bi. So for that, what I am getting? ai minus 2 li dash of xi, right? ai, small ai na, ai into x, right, plus bi. What is bi? 1 plus 2 xi li dash of xi, li dash of xi. This is multiplied by f of xi. This is multiplied by, what is li square? Li square of x, li square of x. This is over, right? And this entire multiplied by what? This is ai entire multiplied by what? F of xi, multiplied by f of xi plus another one 0 to n bi. What is bi? cix. ci means 1, cix means you will get, ci means 1, okay, 1 into x, right? 1 into x ci plus di minus xi, ci plus di into li square, right? Done. Into li square, this is over, into f dash of xi, into f dash of xi, ci plus di, cix plus di into, right? Done. Therefore, Hermite interpolating polynomial is, Hermite interpolating polynomial is p of x equal to summation I equal to 0 to n 1 minus 2 x minus xi li dash of xi multiplied by li of x square into f of xi plus summation I equal to 0 to n x minus xi li square of x into f dash xi. This is Hermite interpolating polynomial. That's it. Where what are lix? Lix are Lagrange fundamental polynomials. Okay, this is Hermite interpolation. In simple way, Hermite interpolation is given by just you remember this, P of x equal to summation I equal to 0 to n ai x into f of xi plus summation I equal to 0 to n bi x into f dash xi, where what is ai of x is equal to, okay, 1 minus 2 into x minus xi li dash of xi multiplied by li square x and what is vix? This is just x minus xi multiplied by li square x. This is Hermite interpolation. Now let us solve one problem based on Hermite interpolation. Given the following values of f of x and f dash x. What is the data? X, f of x, f dash x data is given. Minus 1, 0, 1 are the x values. F of x values 1, 1, 3. F dash x values minus 5, 1, 7. Estimate the values of f of minus 0.5 and f of 0.5 using Hermite interpolation. Okay, the exact values are f of minus 0.5 equal to 33 by 64, f of 0.5 equal to 97 by 64. Now solution. First, given, take the data points x0 as minus 1, x1 as 0, x2 as 1. Therefore, what is n value 2? This x0, x1, x2, n equal to 2 here, right? Hermite interpolation is Hermite polynomial, or otherwise Hermite polynomial is P of x equal to what? Summation I equal to 0 to n. N means what? 2. Aix into f of xi plus summation I equal to 0 to 2 bix into f dash of xi, equation 1. Okay, where what is ai of x? Ai of x equal to 1 minus 2 into x minus xi li dash of xi, this whole multiplied by what? Li square of x, right? And bi of x is what? Bi of x is x minus xi into li square of x. So how many ai's and bi's are there? A0, b0, a1, b1, a2, b2. Let us find those values first. So first one, a0 of x equal to 1 minus 2 into x minus x0 L0 dash of x0 multiplied by L0 square x, right? And here let me explain what is the data point x0 equal to minus 1, x1 equal to 1, x2 0, x2 equal to 1, and what is corresponding f0? 1. f1 1, f2 3, and f0 dash minus 5, f1 dash 1, f2 dash 7. Okay, these are the values. Now coming to the first one, and what is Lix, L0x? Okay, let me write all these. Next one, a1x equal to what? 1 minus 2 x minus x1, L1 dash of x1, this is L1 square x. Next one, a2 of x equal to 1 minus 2 into x minus x2, L2 dash of x2, L2 square of x, right? And what is b0 of x? X minus x0 into L0 square x. b1x is what? X minus x1 into L1 square x. Next one, b2x is what? X minus x2 into L2 square of x. Okay, so let me find first this L0, L1, L2 everywhere is required. Okay, Lagrange's fundamental polynomials. Okay, here what is the first one? L0 x means what? I told you already, not delete the difference 1, x0, write the remaining differences x minus x1, x minus x2 by replace x by x0, x0 minus x2. This is L0 x. What is this? Becomes x minus x1 0, x minus x2 1, right? By x0 is minus 1, minus 1 minus 0, minus 1 minus 1. So this entire is x into x minus 1 by 2. And what is L0 dash of x? X square minus x, x square minus x. So what is this? Becomes x square minus x, 2x minus 1 by 2. And similarly L1x, L1x. What is L1x? X minus x0, x minus x2 by, now replace x by x1, x1 minus x2. This is equal to x minus x0 minus 1, that is plus x minus x2, replace x1, so 0 plus 1 and 0 minus 1. This value is minus x square minus 1 divided by minus 1, so minus x square plus 1. This implies L1 dash of x equal to minus 2x. Next one, L2 of x, this is x minus x0, x minus x1 by x2 minus x0, x2 minus x1. So x minus x0, x minus x1 by, this is value 1, 1 plus 1, 1 minus 0. So this value is x into x plus 1 by 2. And this L2 dash x is what? 2x plus 1 by 2, 2x plus 1 by 2. Therefore substituting all these values, I am getting a0 x equal to 1 plus 3 into x plus 1, 3 into x plus 1, okay, 3 into x plus 1, x square minus x minus 1 by 4. This is a0. After simplification, what I am getting? 1 by 4 of 3x to the power of 5 minus 2x to the power of 4 minus 5x cube plus 4x square. Coming to a1 of x, equal to 1 minus 2 x minus 0 into 0 into x square minus 1 whole square. So this is x power 4 minus 2x square plus 1. a2 of x equal to 1 minus 3 into x minus 1 x square plus x plus 1 whole square by 4. Just I am substituting the values in a1, a0, a1, a2. So this value is 1 by 4 after multiplication 3x power 4 minus 2x power 4 plus 5x cube plus 4x square. These are a values. Now coming to b0, x equal to x minus x0, okay, means x plus 1, x square into L0 square by 4. So this is after multiplication x power 5 minus x power 4 minus x cube plus x square. Next, b1x. b1x is x into x square minus 1 whole square you will get. So x power 5 minus 2x cube plus x. Next, b2x. b2x is x minus 1 into x square x plus 1 whole square by 4. So this is 1 by 4 of x power 5 plus x power 4 minus x cube minus x square. Okay, therefore Hermite polynomial. Substituting a Hermite polynomial p of x formula, Hermite polynomial is p of x into p of x equal to, what is this, a naught x into, what is the formula, a naught x into f of x naught means f naught plus a1x into f of x1 plus a2x into f of x2 plus b naught x into f dash of x naught plus b1x into f dash of x1 plus b2x into f dash of x2. Okay, substitute every value, you know everything, a naught, b naught, and all values substitute here. So 1 by 4 of first one is what, 3x power 5 minus 2x power 4 minus 5x cube plus 4x square, f of x naught value 1 plus a1 value. Now x power 4 minus 2x square plus 1 into this is also 1. Next, plus 1 by 4 minus 3x power 5 minus 2x power 4 plus 5x cube plus 4x square into 3 plus 1 by 4 of x power 5 minus x power 4 minus x cube plus x square into f dash of x naught plus x power 5 minus 2x cube plus x into f dash of x1 plus 1 by 4 x power 5 plus x power 4 minus x cube minus x square, and the last f dash of x2 7. So after simplification I am getting p of x as 2x power 4 minus x square plus x plus 1. This is the Hermite polynomial, right? Now what are the requirements? F of minus 0.5, that is p of minus 0.5. Substitute in this one expression minus 0.5, you will get 3 by 8. You will get 3 by 8. Now another one is what, f of 0.5. F of 0.5, this is value is p of 0.5, that is value 11 by 8. Okay, compare these two values with exact values which are given in the question. Just this is simple Hermite interpolation.